How to obtain a transfer function when Bode plot is given. You can look at the plot. It is drawn between magnitude in decibels on y-axis and frequency on log scale on x-axis. This plot is actually known as asymptotic plot or approximate magnitude plot, and you can see the variations in the slope. It starts from a slope of minus 40, then minus 60, and then minus 40, and then minus 60. These parameters 2, 5 and 25, they are known as corner frequencies. This consists of 3 corner frequencies. And to get a transfer function, it involves or it consists of some poles, some zeros, and some poles at origin and gain constant. So 4 options are given here. When you look at all the options there is a 0 at s is equal to minus 5 and 2 poles at origin, 1 pole at minus 2 and the other one is at minus 25. So it is true that the 0 and the poles are same in first 3 options. The only change is there is a gain constant 5, 10 and 40. So we need to get which one is the right answer for the given magnitude plot. This is a transfer function. So which transfer function is for this Bode magnitude approximate plot? So first step is to identify the corner frequencies, and the second step is when you look at the plot starts at 54 having a slope of minus 40. So I can say that g of s into h of s in the denominator, because of minus 40 dB there are 2 poles at origin. That is the indication of minus 40 slope, 2 poles at origin. As usual, there will be a k gain constant that we need to find out. And when you look at this minus 60, change in slope from minus 40 to minus 60 is at 2, the corner frequency. That means minus 20 is added. Minus 20 is added at this corner frequency 2. That means a pole is added because pole has negative slope. So I can say that it is 1 plus s by 2, where 2 is the corner frequency, the slope changes from minus 40 to minus 60. Next, when you look at this corner frequency 5, the slope has become minus 40. That means minus 60 to minus 40, certainly a 0 is added. So where the 0 is added? At this corner frequency 5. So numerator term 1 plus s by 5 is the 0 added. So the net slope has become minus 40 because plus 20 is added to minus 60. Now when you look at the third corner frequency 25, the slope again it has become from minus 40 to minus 60, means a pole is added. So the pole is added at corner frequency of 25. So this will be the transfer function. By looking at the corner frequencies and the net slope, you can estimate where the pole is located and where the 0 is located. This is called time constant form of representation. Now our interest is to find out the value of k so that which option is correct from this. So there is a magnitude given here 54. So that 54 is at this frequency omega 0.1. So I can say that g of s into h of s at omega equal to 0.1, the magnitude of the plot is 54. So we need to equate this to 20 log k, first term, and there is a change in slope minus 40. So minus 40 log omega. So it is at 0.1, the slope actually begins to minus 40. So 54 is equal to 20 log k. Our interest is to find out the k minus 40 log frequency at 0.1 radians per second. So this becomes plus 40, so it becomes 14 is 20 log k, and log k is equal to 14 by 20, 0.7, and k is equal to 10 to the power of 0.7. So the value of k is 5. So once you see the value of k equal to 5, first three options, as I said, 0 and poles are same, but only change is the gain constant. So k is 5, so option A is the right answer. So answer is option A. So this is the way we need to find out the transfer function from the given Bode magnitude plot. Magnitude plot is given once again here. Look at the plot. It has a constant slope at 20 magnitude, then there is a change in slope S1, and again there is a change in slope S2 at 10. So the question here is find out slopes S1 and S2, and then find transfer function. Slightly different problem, and slopes are to be determined here. So there is an expression which gives the relation between y coordinates, x coordinates and slope. A general formula, the slope m is given by y2 minus y1 by x2 minus x1. So that way, if I want to find out the slope S1, you can see the y-axis coordinates 140 minus 20, that is y2 minus y1, then x2 minus x1 log 10 minus log 0.1, because these frequency parameters are taken in log scale. So from this you will get the value of slope S1 is equal to 60. Both y and x coordinates are given, but only slope is not given. So S1 is determined using this mathematical formula for slope. Similarly, S2 can be determined. S2 is the slope changes at 10 corner frequency. So this is again 160 minus 140. They are the y coordinates for this S2, divided by log 100, that is x2 minus log 10. So the numerator 160 minus 140 is 20, and log 100 is 2, and log 10 is 1. So the slope is 20. So S2 is 20. So you got now S1 as plus 60 and S2 as plus 20. Now we need to obtain the transfer function as soon as the slopes are obtained. So you can actually get g of s into h of s. As you know, it consists of k. Now you can see that the slope actually begins to plus 60 at 0.1, that is the corner frequency. That means it is a 0 because having a slope of positive value, and for every 0 the slope is plus 20, but here the slope is plus 60. So I must write 1 plus s by 0.1 is the corner frequency for the 0, but being a slope of plus 60, I must write whole power 3. So 1 plus s by 0.1 whole power 3, this 3 is because of plus 60, divided by, now there are the plus 60 has become plus 20 from corner frequency 10. So plus 60, the result is plus 20. That means plus 60 will become plus 20 only when you add minus 40, the meaning of minus 40 at corner frequency 10, there are poles. Such poles are 2. So I must write 1 plus s by the corner frequency where the slope changes to plus 20. The value is 10, but minus 40 means such poles are 2. So I must write whole square. Then at 100, the further it continues, slope changes there, 1 plus s by 100. So this will be the loop transfer function for this magnitude plot, and I need to get the value of k also here. You can see the magnitude is constant 20 and no slope actually. So I can write this magnitude 20, that is g of s into h of s, magnitude at omega is equal to 0.01 is equal to k into the whole function 1 plus s by 0.1 whole power 3 divided by 1 plus s by 10 whole square into 1 plus s by 100. So this magnitude at omega equal to 0.01 is given from the plot 20, and that must be equated to 20 log k. So k is now 10. Okay, so log k is 1. So k value is 10 power 1, and you will get the value of k as 10. So this is the way we should determine the value of k, equate the magnitude to 20 log k, because there is no change in the slope at omega equal to 0.01. That's why only constant term will appear, and you will get the value of k in that way. Couple of definitions require in frequency response plots. What exactly the minimum phase system is? So minimum phase system, MPS, is nothing but it is a system with all its finite poles and zeros lie in the left half of the S-plane. Minimum phase system is a system with all its finite poles and zeros must lie in the left half of the S-plane. For example, I can call MPS as S plus 2 by S plus 3 into S plus 4. When you look at the system, it consists of two poles at S is equal to minus 3 and minus 4, and the zeros at S is equal to minus 2. So when you locate them in the S plane, the 0 is at minus 2 and pole is at minus 3 and minus 4 in the S plane. So why is it called minimum phase system? So when you look at this minimum phase system, the phase angle, for example, if I want to have a phase angle of the function, then it is given by tan inverse omega by 2 for 0 and minus tan inverse omega by 3 for a pole at S is equal to minus 3 and minus tan inverse omega by 4 for the other pole. So when you look at this phase angle at omega equal to 0, this phase angle will be 0. So that is the reason why this is called a minimum phase system. A system with all its poles and zeros lies in the left half of the S-plane. The next definition is an all-pass system. All-pass system. So it will have it will have the zeros lies in the right half of the S-plane. For example, if there are two complex zeros, then symmetrically there are two poles, complex poles in the left half. If there is a zero in the right half of the S-plane on a real axis, then there will be a pole exactly symmetrical to the imaginary axis or real axis. Then you have a pole, then this is called all pass system. That means what will be the magnitude and phase angle? So when you look at this, say APS S minus 1, that means there is a 0 at S is equal to plus 1. Then there is a corresponding pole in the left half of the S plane at S is equal to minus 1. So I must write S plus 1 here. Then this complex zeros, say S square plus 2S plus 2, then complex poles S square plus 2S plus 2. So the magnitude becomes 1 for such all pass system, and the phase angle is 180 degrees. Phase angle is plus or minus 180 degrees. Such a system is known as all pass system. This is the Bode magnitude plot, and the data given, we can actually see the slope begins from 32 dB, and at minus 20 it continues up to 6, and the question here is find out the value of omega 1 and omega 2, and also find the transfer function and the k value. So this many parameters can be determined from the given magnitude plot. So in order to determine the value of omega 1, it is the corner frequency, you can use the mathematical expression like as I said, the slope m is equal to y2 minus y1 by x2 minus x1. So you can see these coordinates, minus 20 is the slope, and that is equal to y coordinate 6 minus 32, and the x coordinates omega 1 and 0.1. So it must be written in log omega 1 and log 0.1. So this we can write log 0.1 as log omega 1 plus 1, that is equal to minus 26 by minus 20. So this becomes 1.3, and 1 goes this side, so log omega 1 is equal to 0.3. Now omega 1 is the corner frequency, it is equal to 0.3, and the value is 2 radians per second. So the corner frequency omega 1 should be determined from this data, slope of the line, y coordinates and x coordinates. Omega 1 you got as a 2 radians per second. Now next we need to determine the omega 2. So again you can see at omega 2 the slope is actually changing to minus 20. So I must equate for finding omega 2, the slope is minus 20, changes from omega 2 up to 10, corner frequency. So this is 0 minus 6 as y coordinates, and x coordinates are log 10 minus log omega 2. So omega 2 is 10 power 0.7, this is again 5 radians per second. So always you can cross check the answer. Omega 2 you got 5 radians per second, it is lying between omega 1 which you got 2, and this omega 2 is 5 because it lies between 2 and 10. So that way you can cross check that your answer is right. So omega 2 is 5 radians per second. Now you have got all corner frequencies here. There are 1, 2 and 3, and the slope actually begins at 32. From that you can find out the value of k. So you can write now the loop transfer function g of s into h of s. It involves k. And you can see now the minus 20 has become 0 here. This is a 0 slope. That means this is a pole having a slope of minus 20. But from this corner frequency omega 1, the slope has become 0 from minus 20. That means minus 20 becomes 0 only when plus 20 is added. That means there is a 0 at omega 1 corner frequency of 2. So I can say that in the numerator you will have a term of 1 plus s by 2, and in the denominator you must always see that the beginning of the plot is having any slope. If it has a slope of minus 20, I must write there is a pole at origin. If the slope has minus 40, then I must write here s square. So there is minus 20, there is only one pole at origin having a slope of minus 20. Now next one, you can see here the slope begins again from this point 0 to minus 20. That means there is a pole again located at minus 5. So corner frequency of 5, the slope actually begins. So there is a pole at 5. So with corner frequency 5 you have one term, and you can see again at 10 the slope changes to minus 40. So minus 20 has become minus 40 at corner frequency of 10. So I must write as 1 plus s by 10. Now this is the loop transfer function. Our interest is to find out the value of k. Always you must see that the magnitude of the given function at omega equal to 0.1 is 32, the highest value 32, that must be equated to 20 log k because it is expressed in decibels, and as the plot begins with a slope of minus 20, so we must write here minus 20 log omega if there is a slope at omega equal to 0.1. So now this omega you need to have the value of 0.1, and 20 log k, okay, minus 20 log 0.1 is equal to 32, and from this you should get the value of k as 10 0 power 0.6, and it is equal to 4. So the value of k is 4, and there is 1 0 at 2 radians per second with corner frequency, and there are 3 poles. So this will be the loop transfer function which can be obtained from the given magnitude plot.